So what's meant by a hexose versus a pentose? What's meant by an aldose versus a ketose? We're not going to learn to recognize glucose versus galactose. Or if you go back to Biology 111, what about alpha glucose versus beta glucose? What about D-glucose versus L-glucose? What about D-alpha, D-beta, L-alpha, L-beta? No, we're not going to do any of that. Just generic, generic, generic. So it made no difference which side I put those things on. I just made it up. Made it up. Now this is all well and good, but the problem is, as you should all remember and probably do, sugars don't look like this in the body, do they? Nope. In the body, they form rings. We just show them like this so we can understand them. Now these vertical bars I'm drawing represent these horizontal lines here. As you know, there's a carbon at this corner. And if you look over here, the carbons have a hydrogen and a hydroxyl group. So we can put the hydrogen and the hydroxyl group there if we wanted to, but we don't want to because it's a waste of time. Maybe your hexagon can be a little more symmetrical than mine is. Now, we looked at these pictures a minute ago in some other context. Oh, I remember now to differentiate between words like hexane, hexagon, hexose. So this is a hexose, yet I only see 5 carbons in the ring. One member of the ring is not carbon. That's why it's shown. That's what you have to do. If it's anything other than carbon, you have to show what it is. One of the carbons is outside of the ring. So you can take this to the bank. Any hexaldose will be a hexagon. Now our hex ketose looks different in nature. I've got a 5-sided ring. I've got a pentagon. 4 carbons are in the ring, but I've got 6. So that means I must have 2 that are not in the ring. So I've got a CH2OH in 2 places. In other words, what the CH2OH is, it's like that. Just condense it and call it CH2OH. So I still have 6 carbons. In biochemistry, any hexaldose will be a 6-sided figure. In biochemistry, any hex ketose will be a 5-sided figure. We don't care about what we can go into the lab and synthesize. We're talking about molecules of life. And so along those lines, let's go back to this for a second. We started it with our 6 carbons. And I just said in biochemistry, any hex ketose will be a pentagon. You don't have to say, but Larry, what if that double bonded oxygen was on carbon 3 instead of carbon 2? It won't be. Never, ever, ever in biochemistry. And if it was, Even if you went into a laboratory and built this, which you could do, it wouldn't form a ring. You know why it wouldn't form a ring? Because for this to form a ring, it would have to be a square. And the angles between the carbon atoms, remember this? The angles between the carbon atoms aren't 90 degrees. It can't form a square. So if you went into a laboratory as an organic chemist and synthesized this, it would look like that. It would be a chain. Just like we saw how pentane could form cyclopentane. We saw how hexane could form cyclohexane. The bond angles allow that. But butane doesn't form cyclobutane because it would be a square. Propane doesn't form cyclopropane because it would be a triangle. The only things that can form rings are things that the bond angles allow for. So you can, once again, take this to the bank. If it is a hex ketose, it will have pentagon geometry. I wrote down a little earlier this morning examples of most common monosaccharides. You see those in your notes. Please get to where you see them. And what's the first one I wrote down? Glucose. Okay. This is the way glucose looks. What's the second one I wrote down? Galactose. It looks the same way. What's the third one I wrote down? Fructose. Fructose is a pentagon. Keep this where you can see it. You're about to apply it. Disaccharides. Also simple sugars. We'll stick with groups of three. We had three monos, glucose, galactose, fructose. I'll give you three dyes. Sucrose, table sugar. Lactose, milk sugar. Maltose, from the breakdown of starch. Sucrose is made of glucose and fructose. Lactose is made of glucose and galactose. And maltose is made of glucose and glucose. Okay, that stuff I just erased. Remember I said keep this where you can see it. You're about to apply it. Here we go. Which of these disaccharides could that not be a picture of? You are correct, but you don't get the points unless you can tell me why. Go ahead.
Because a fructose is a pentose. Not as a pentose, it's a pentagon.
Pentagon. There's those notes I said just not even 5 minutes ago. Keep that where you can see it. You're about to apply it. Maltose is made of two glucose molecules. Glucose is a hexaldose having hexagon geometry. We have two hexagons here. Lactose, same thing. Glucose and galactose. Glucose and galactose are both hexaldoses. They both have hexagon geometry. We have two hexagons. Sucrose, one of its components is fructose. Fructose is a hex ketose. A hex ketose has pentagon geometry. So sucrose, we would need to have a molecule that had one hexagon and one pentagon. Generic stuff, guys. That's all we're doing. Very, very generic stuff. But I have one more thing before we go. We will begin. I'll go ahead and put my little marker here. We'll begin with the polys on Wednesday. But I have one more thing to point out here. If we go back to the solutions math and all of that, aren't you just supposed to know the molecular weight of a hexose sugar? Because it'd be a waste of time to have to calculate it. Kind of like, sodium chloride's 58.5. Or is it 54.5? What is it? 58.5. So what's the other thing you're just supposed to know the molecular weight of? So that's what any hexose, 180 grams per mole. Is that right?
Yes.
Okay. Now, is glucose a hexose?
Yes.
So what if we take glucose, molecular weight 180, plus galactose? What's the molecular weight of galactose? 180. And we combine them to form, what do you get when you combine glucose and galactose? Lactose, milk sugar. Why is it not 360? What type of reaction is this?
Dehydration synthesis.
Dehydration synthesis? How does dehydration synthesis work? We combine two subunits, we form a dimer plus water. Where'd the water come from? Took a hydrogen from one of these, a hydroxyl from the other. What's the molecular weight of water? 16 for oxygen. All right, guys, I'll see half of you upstairs for the lab for your 2 tests. The rest of you I will see on Wednesdays.